Welcome to an NYNJPA weather education video. Today we're going to talk about satellite data. Now, you can get satellite data from pretty much any weather source, but I like to go right to the main source, which of course is the National Weather Service. Very easy to find. In fact, let's do this right now. All you really have to do is type in on Google NOAA Satellite Information Services. And this is the heart of where you want to get all your satellite data from. It's raw, it's generous as far as being able to find all types of different versions of satellite data. It's one of the best sources out there because it also gives you an explanation on how to use them all. You can take a look at the ocean basins, you can do land sectors, composites, zoom in on tropical systems. For today, we're going to take a look at a few of the basic satellites and how to use them properly and why I like to use each one in specific situations. So today we're going to focus on the visible, the shortwave, water vapor, the AVN, Dvorak, this is important, and JSL. These other satellite images down here are more of just a different look of the AVN, to be honest with you. They give you a little bit of a different look, so some people like more reds, more blues. So these different satellite options give you those capabilities for a more of a graphical feature on your website or if you're doing a newscast. So first we're going to take a look at the visible. The visible satellite picture is one of the first ones that we ever had, and it's really unique in the capability of being able to see details in the cloud patterns, especially when the sun is up. The one drawback, of course, is when the sun is not up, it's not very useful. Now, we've improved our satellite data, especially for the surface. You can see this line here is the movement of the sun. And when the sun is set, we do get a little bit more information than we used to with the visible satellite picture. Beforehand, it was just black. Now we get a little bit more of a kind of a highlighted infrared type look here. But clearly, the full capabilities of the visible satellite picture comes to bear when we actually have the sun up. And you can see the better details in the cloud patterns where cold air is rushing over a warmer ocean. Thus, you get this type of cloud pattern, more of a stratus form with some cirrus mixed in. You're able to see more low clouds in your valley locations. And as you zoom in, you can get even more detail on where that fog is setting up. See the capability of where, let's say if it's in the summer and you're looking for a severe event, where are the clouds breaking up and where is the sunshine really setting up to really warm up the lower portions of the atmosphere. And also you could pick out where cumulus clouds are starting to form out ahead, let's say over central Pennsylvania or in the plains around the panhandle of Oklahoma. That would tell you whether or not thunderstorms are going to develop and whether they'll have the capability of becoming strong or severe. So there's a lot of uses that you could use with the visible satellite picture, specifically picking up details. In tropical weather, you could see the formation of an eye better with a tropical system. And also you could see, in some cases, better formation of the upper level low and surface low of a nor'easter. So this is a really important tool to use and one that allows you to pick up some of the smaller nuances of what's going on in the weather pattern. Now this is infrared channel 2. Now what that basically means is that it's taking the infrared satellite data of the colder cloud tops, but it's highlighting more of what's going on at the lower temperatures. And what that basically means is that it allows me to pick up some of the lower cloud tops and mid-level cloud tops to see if any fog is forming. Infrared satellite pictures are excellent for picking up explosive cloud development, which I'll talk about in a moment. But it kind of lacks in the capability of picking up low clouds and fog because the temperatures of the ground and the clouds are very close to each other. You see, infrared satellite pictures, which is right here, are based on the idea of the ground is warm and the cloud tops are cold. Therefore, the colder the cloud top, the higher the cloud top, and of course, the higher the cloud top, the more intense lifting. Well, the problem with that is that in two cases, it doesn't always pan out very well. For example, when you have a very cold Arctic air mass, let's say around the Great Lakes, what you end up with is a whole lot of blue here because the ground is so cold. It actually starts to pick up on the temperature scale here of light blue. So if you see a really strong uh, Arctic air mass and you want to see where it's moving, take a look at the infrared satellite picture and see how that light blue starts to expand from Canada all the way down into the Great Lakes and eventually towards the northeast. That's when you know you have an Arctic air mass because that is some cold temperatures. But let's take a look at the current one right now. You see all these oranges and reds. That means that the cloud tops are very cold. Now this tops out usually at minus 80 degrees Celsius, which is pretty chilly. And when you get temperatures that cold on the cloud tops, that means the cloud tops are very high in the atmosphere. And like I said, that means that there's intense lifting. And typically that translates to heavy precipitation, storms, significant tropical development. During the winter, we'll see a lot of explosive development out here over the Gulf Stream. That means that a coastal storm is starting to intensify and could also mean the transport of very heavy precipitation into the coast. In this current satellite picture for today, you can see a cold front that's moving through with the majority of the lifting falling apart here. Notice the cloud tops are warming. That means that lifting is weakening, and that means that this cold front is weakening. Meanwhile, over the southern plains, we're seeing an increase in cloud top temperature in the colder cloud tops, and that means that lifting is increasing. It's increasing as this low pressure system lifts off into the northern plains. So what the infrared satellite picture tells us is whether or not we're seeing storms intensify, whether we're seeing stronger lifting developing, because we're seeing the full nature, the full spectrum of those cloud tops growing in height, which we really can't see all that well in a visible satellite picture. We can to some degree, but not to the degree that you get with an infrared satellite picture. But notice the drawback here. We know we have fog here over portions of northeastern Pennsylvania and southeastern New York, especially around the Hudson River Valley. But you can't see it very well because the cloud tops are very close to the ground temperature, so it barely shows up. That's why when we take a look at the infrared satellite picture, we get a little bit better indication here. Another satellite picture you could use, called the JSL, is another one that picks up low clouds a little bit better and illustrates where those low clouds are setting up. You still have your indication of all the higher cloud tops here and the medium cloud tops in white, but you also get a better spectrum of where the lower cloud tops are setting up. And then, of course, your clear skies. All infrared satellite pictures, though, are going to have the drawback of when there's temperatures too cold at the surface, it tends to produce way too much blue, and the infrared satellite picture loses a little bit of its data capability. As long as you're able to adjust for that, you'll be fine. Now, this is my favorite satellite picture, the water vapor satellite picture. To be fair, I fell in love with this satellite picture when I was a child watching Jim Cantori on the Weather Channel. This is a satellite picture he always brought up to kind of illustrate what's going on with the atmosphere. And I guess I've kind of followed that lead because I constantly use this website and this satellite picture, should I say, to illustrate what's going on in the atmosphere. Now, the water vapor satellite picture basically takes an image of all of the water vapor that sets up in the atmosphere, okay? And you could see the development of the 500 millibar pattern with the water vapor satellite picture. You can see a very impressive trough here over the Hudson Bay. And you can see a separation in the jet stream between the polar jet stream coming out here, the subtropical jet stream here, and an upper level low that's cut off the mid-Atlantic coast. And we can also see that this upper level low is starting to become hooked up once again with our polar jet stream. The key point here is that you're able to pick up where air is rising and sinking. This red here, that's dry air. Now, when you see a lot of red next to a lot of white and blue, and in some cases orange and red, what that means is that air is rising and sinking rapidly. When we have a very strong low pressure system like we're starting to develop here, Notice we're seeing divergence aloft. We're seeing a lot of rising air here, and look at the counter of that rising air, all that sinking air, very sharp, very well defined. Now, you use the satellite picture with the combination of what you know is going on in the atmosphere. For example, if you see a lot of red and black setting up over the southeast, and you see that this jet stream is kind of setting up like this, what does that mean? That means we have a ridge. So all that red and black, let's say in the summer, means we have a lot of sinking air, a lot of dry sinking air, and that dry sinking air sitting over a high pressure system in August would typically suggest we're going to have very hot temperatures. Conversely, let's say we have an area of low pressure that's developing off of the southeast coast. We see a lot of whites and blues starting to develop, and then conversely, we see more and more reds and blacks. What does that mean? It typically means that we're starting to see a coastal low pressure system intensify or develop. So in this case, we're seeing our low pressure system trying to hang on off of the mid-Atlantic coast, trying to get itself a little bit better organized. But this cold front and this upper level trough is going to pick up this low pressure system and send it out into the Atlantic. We know this by the way that the water vapor satellite picture is setting up the upper level winds here, and we can see that very clearly with the moisture. So the water vapor satellite picture gives us a lot of clues on the dynamics of what's going on with the storm, where air is rising and sinking, and how the jet streams are interacting over a specific location. So when you have a lot of convergence aloft, you're going to tend to see a lot of black and red because that means air is sinking and drying. When you're seeing a lot of divergence aloft, like you're seeing here, you end up seeing a lot of whites, blues, yellows, and reds because that means air is rising, and that means that more precipitation is being developed and more water vapor is being lifted up into the atmosphere. The next satellite picture is called the Dvorak Satellite picture. Now, this is a really cool satellite picture. It's developed to pick up not cloud heights, although it does do that to some extent, but cloud formation. You see, we didn't always have planes being able to fly out into the middle of the Atlantic to pick out what's going on with the latest tropical system, and we didn't have the best communication with ships out there. Now, we've improved, but we're not there yet as far as having a true network. So we developed a way to use satellite pictures to pick out cloud patterns that tell us whether a low pressure system is developing. This is really key when you're dealing with the tropical hurricane season and out in the Atlantic, and it's the eastern Atlantic, and you really don't have a lot of observations, but we have satellites. So if we could pick out the cloud patterns of tropical depressions and tropical storms and hurricanes forming, then you can make a estimation of what's going on out there and the potential for strength that is developing. So what they've developed is what's called the Dvorak chart. And these are common development patterns in the clouds of tropical depressions, storms, hurricanes, and very intense hurricanes. For example, T8 would be something like a hurricane, any strong hurricane, really. A Hurricane Sandy, for example, when it was really intense. I know I'm forgetting one major one, of course. Katrina, hello. Hurricane Katrina would have been a T7, T8. So what this allows us to do is that even though we don't have observational data out there in the eastern Atlantic, it allows us to pick out these cloud patterns and say, hey, we need to keep an eye on this disturbance because it looks like it's forming a low-level circulation, and it looks like it's becoming a tropical depression and a tropical storm, and this is a strong tropical storm, and you can see the progression here as we move forward in time. That as we get stronger and more impressive with these tropical systems, there's specific cloud patterns that develop as a result of the intensity of those low pressure systems. And as you can see, the system is basically set up by one or more of the following numbers. So if the system is center becomes very defined around it, and you're at 1, okay? Dense overcast and system center becomes more clearly associated. You're down to 2. CDO starts to form and is rounded. Well, look what we have here. 3 and then 4 overcast banding encircles the center feature. Now we're at 4, and then clearly at 5 we're starting to move into the hurricane areas with a large eye and so on and so forth. So this is basically an answer to being able to pick out cloud patterns to figure out whether tropical systems are developing when we don't really have any significant observational data out there. Because after all, no one's going to tell a ship to go out into the middle of a hurricane and pick up some data. Not going to work that well. But if you have a satellite picture like this, well, you can save a lot of lives and get a lot of data. That is the educational video for today on satellite data. I hope you enjoyed it and learned some things on how to use these satellites properly and at the correct times. And of course, you'll see me use them throughout the winter as we get ready for all of our winter storms and active winter weather patterns. Thank you again for joining me for this educational video. Of course, I'm your meteorologist, Stephen DiMartino. Have a wonderful day, and as always, stay safe out there.